So the next algorithm is optimal page replacement. Already we have discussed FIFO with the number of free frames and the number of page fault. Okay. Second algorithm is page replacement with the optimal page replacement. So to say it one sentence, optimal page replacement means replace a page that is not going to be used for a long time. Okay, future tense. Replace a page that is not going to be used for a long time among the references given in the problem or in the question. Okay, among the references that are given in the given as a memory references, reference string. Okay. Let us consider this example, same example. Okay, let us have 3 free frames. Okay, of course, you can have 1, 2, 3 as per your requirement. For easy understanding, I am having 3 free frames. I am going to use this as input reference string, and my ultimate aim is to find out the number of page fault. Okay, so initially the main memory is free. I have 3 free frames. So first reference is 1, which is not available in main memory. So one page fault will occur. I will copy page number 1 to the main memory. Second reference is 2, not in main memory. So page fault 2. Third reference is 3, not in main memory. So now 3. Now we should be very careful. Okay. Now this is the reference I want to copy into the main memory. Page number 4, which is not available in main memory. So in FIFO, I will replace 1 because that came first. But in optimal, I have to replace a page which is not going to be used for a long time among the references available in main memory. So among 1, 2, 3, which is not going to be used for a long time, that you have to refer here. Okay. Now consider 1, which is going to be referred immediately. 2, again next to 1. 3, which is not going to be used for a long time. Correct? So up to this I am not going to use, but before that I will use 1 and 2. So I will replace 3. Page fault will occur. So page fault, I will replace 3 with 4. Okay. Now listen carefully. Next, the reference is 1, which is available in main memory. So no page fault. 2, already available in main memory. So no page fault. Now assume 5, which is not in main memory. I have to replace. Just think and tell which page will be replaced. Okay, which page will be replaced? Among 1 to 4, I have to find out a page which is not going to be used for a long time in this reference. Okay, so 1 I am going to use immediately, 2 again I am going to use immediately, 4 I am not going to use immediately. Okay, after 1 and 2 only I will use 4. So I will replace 5. Okay, I will replace 5 here, page number 5 here. So one page fault will occur. Correct? So next is 1 and 2, which is already available in main memory. So no reference, no page fault. Now consider 3. Now you can answer. Okay, consider 3. Among 1 to 5, which is not going to be used for a long time. 5 I am going to use. 1 and 2 I am not going to use for a long time. So here you can use anyone, either 1 or 2, no problem. Or simply saying first come first serve. 1 will be replaced by 3. So one page fault will occur. Then 4. Again, 5 is going to be used. You can replace it with 4. The total number of page fault is 7. I hope you understand. Okay. Replace a page which is not going to be used for a long time. Able to understand? Okay, consider one more example. Quickly I will explain with one more example. So initially memory is free. So first 3 page fault, 1, 2, 3 page fault will occur. Now the reference is 1, which is available in main memory. So no page replacement. Now I have to include 4 in the main memory. Which page to be replaced? A page which is not going to be used for a long time. So here you are having 1, 2, 3. Among 1, 2, 3, which is not going to be used for a long time. 1, here we are using it immediately. 2 in this place. 3 is not going to be used for a long time. Among these 3, 1, 2, 3. So I will replace 3 here. 4 will be replaced. So one page fault will occur. Again 1 which is already available in main memory. Now consider 5. Okay, page fault. Surely page fault will occur. Which page will be replacing? Among 1 to 4 which is not going to be used for a long time. So here 2 is available first and 1 is available first. 4 is not going to be used for a long time. In fact, 4 is not in the reference itself. So here I can replace it with 5. Okay, now 6. Again, which is not going to be used for a long time among 1, 2 and 5. So here 2 I am replacing. So sorry, 2 I am going to use immediately. 5 I am going to use immediately. 1 is not going to be used for a long time. Now I will replace 1 with here. Okay, next 7. Among 6 to 5, which is not going to be used. Among 6 to 5, here 2 is there. Here 6 is there. Here 5 is there. 5 is not going to be used for a long time. So I will replace with the 7. So page fault will occur. Then 2, which is already available in main memory. Now consider 3. Okay, among 6 to 7, which is not going to be used. 6 is there, 2 is there, 7 is not there. So I will replace here 3. One page fault will occur. 6 already available in main memory. 5, I have to replace 6 to 3, which is not going to be used. 3 going to be used. 2 going to be used, 6 is not going to be used. So here I will replace 5. So one page fault, 3 already available, 2 already available, only 1. So any memory reference you can replace. Okay, no problem. But according to algorithm, first come, first serve means you can replace 2. 2 is staying there for a long time. So I will replace with, okay, page fault will occur. Okay, just to see the right hand side of the memory reference. Among the references that are available in main memory, you see what is not going to be used for a long time in the reference based. Okay. Third algorithm is least recently used page replacement algorithm. Okay, LRU page replacement algorithm, which is straight opposite to optimal replacement algorithm. Okay, in optimal replacement, what we did? A page that is not going to be used for a long time. Okay, that we replaced. In least recently used, which is already used long before. Okay, which is already used long before. That place we will use. Okay, least recently used. Just opposite to recently used. Recently used means what? Just now I have referred. So least means among the memory references or page numbers that are available in main memory, what is the page number that is used or referred long before? Okay, optimal means not going to be used for a long time. Least recently used means long before. Okay, so straight opposite to optimal replacement. Let us see one example. Consider this example. In main memory, we are having 3 free frames. Okay. So what is the first reference? 1 is the first reference. As far as we are having 3 free frames, so 1 will be stored here. Page default, we will have 1. Okay, initially page default is 1 because 1 is not available in main memory. So 1 is copied to main memory from secondary storage. Second reference is 2. Still I have free frame, so that will be loaded here. So another page default will occur. And third reference is 3. Still I have free frame. 3 will be stored here, another page default. Okay, 4 is not available in main memory. So I will replace, or I have to replace among these frames, any one of the frame. Okay. Now listen carefully. in LRU, we have to look before among the frames that are available in main memory, what is the oldest frame or not recently used frame. So here we are having 1, 2 and 3. So from 4, I will check 3, 2 and 1. 1 is the oldest frame or 1 is the not recently used frame. So I am replacing 1. Consider this here. It is as the same as FIFO. Okay, in first out also we are replacing the first come first serve. So here 1 is the first come first serve. So we are replacing almost the same. Let us see when it will differ. Okay. Next is 1 not available in main memory. So for page 4 also we are having 1 page fault. Okay. The next frame is 1 not available in main memory. So page fault will occur. Now what will be replaced? Among 4, 2, 3, what is the oldest? So here we have to check. Among 4, 2, 3, 2 is the oldest. 1 will be replaced here. Okay. So now again, next is 2, which is not available in main memory. So page fault will occur. Among 4, 1, 3, what is the oldest? Starting from 2, we have to check. So 1, 4 and 3. 3 is the oldest. Here we will replace 2. Okay. Now listen carefully. 5 is coming. So among 4, 1, 2, what is the oldest? 2, 1, 4. This is the oldest. So here I will replace. So one page fault will occur. Okay. Next, consider 1, which is already available in main memory. So no page fault. Consider 2, already available in main memory. So no page fault. Now consider 3, not available in main memory. So page fault will occur. Now listen carefully. Among 5, 1, 2, what is the oldest frame? All or least recently used frame we have to check. So here 2, 1 and 5. 5 is the oldest here according to this. Okay. So now I will replace 5 with the 3. Okay. So if it is first come first serve, it will replace 1. Correct? If we follow first come first serve, we will replace 1. But as we are following least recently used, now I am replacing 5 with the 3 in this place. Okay. 1 will be replaced according to first come first serve. Now according to least recently used, among 5, 1, 2, which is oldest in this reference we have to see. Okay. So 5, 1, 2. So here 2 is there. Here 1 is there. And 5 is the oldest one. Instead of 1, I will replace 5 with 3. So one page fault will occur. Okay, now listen carefully. 4, which is not available in memory, what we will replace? Among 3, 1, 2, which is oldest, I have to see. 3, 2 and 1. 1 is oldest, so I will replace it with 4. So one page fault will occur. Now 2 already available in main memory, 4 already available, 2 already available, 3 already available, 4 already available. Now listen carefully, I have to replace 6. Okay. So among 3, 4, 2, what is the oldest reference? 4 is there, 3 is there, and 2 is the oldest reference. So now I will replace 6. So total are 10 page fault. Okay, now you can take your own example and try it on your own with the different frames and check out the number of page fault. Okay, so 3 algorithms we have discussed. FI, FO, first in, first out, then optimal. Replace a page which is not going to be used for a long time, least recently used. Replace a page which is used, not recently used. That is least recently used. Okay, thanks.